Alright, this whole lesson is going to be about 7.3 special products of polynomials. The important thing is just to notice a certain special situation at the beginning, which will kind of help you speed up your work a little bit more. When you're doing these problems, you can always go back to the old way, whether you're using table method or FOIL or just kind of a modified distributive property. However you want to do it is fine. But if you start recognizing the pattern, it'll make your life a lot easier, a lot more, it'd be a lot more efficient. Okay, so one of the first concepts, so I'll kind of zoom in here, is called a square of a binomial. So a plus b, if you have the same thing twice, hence the squared, it'll end up being the formula a squared plus 2ab plus b squared. So what does that look like with a real problem? So say you have x plus 5 squared. Okay, there's your a, there's your b. We can just do x times x, x squared. Then you have your 5 times 5, which is over here. Then we have our 2ab in the middle. You have your 2 pulled out front, and then you have your a, x, and b, which ends up giving you 10x. Okay, a lot easier that way. You could do the FOIL and do at first, outers, inners, and lasts, but it makes it a little quicker when you know that you're doing the same thing multiplied by itself. For this, for subtraction, it's the same exact thing. The only idea is that this plus becomes a subtraction since you're actually end up combining like terms if you were to write it all out. So you go ahead and do the same thing. 2x squared is actually 4x squared. Negative 3 times negative 3 is a positive 9. And then 2ab, 2 times our a, 2x times 3. All right, let's kind of look at it, some examples and give you an idea of what it looks like. So the first one, find each product. 3x plus 4 squared. So write it out. A plus b. We have our a right there. 3x squared ends up being 9x squared. And then we have our b over here. 4 times 4 is 16. Okay. And then we have our middle terms, 2ab. Ends up getting us 24x. All right. If you want to see it the old way to show you that it does work, it just makes it a little faster, we can write it out. 3x plus 4 times 3x plus 4. And like I said, you're still free to do it this way. Just makes it a lot faster if you know that this is a special case. 3x times 3x is still 9x squared. That's the first. Now let's do the outers. Right there. 3x times 4 ends up giving you 12x, so plus 12x. Let's do our inners. So the 4 and 3x, again another 12x. And then we have our last 4 times 4 is 16. So you notice when you combine these like terms here, you should notice that we get the exact same answer. So just one of those special cases that makes it go a lot faster if you know that that is a special case. All right. For letter B, you notice the same exact idea. Same thing multiplied by itself, squared. Only difference is its subtraction sign. So let's kind of write that out. 5x, 5x, the b goes over here, b over there, 2ab in the middle. Make sure that subtraction sign stays there, and go from there. All right. Example, okay, next one. Next special case, sum and difference pattern. So you'll notice it's the same a's and b's, but the difference is that there's a plus in the first one and subtraction in the second one, or vice versa. Because they're opposite, the middle digit, the normal 2ab you used to seeing in the previous example, is gone. Okay, so what would that look like? We see in this problem x plus 3 multiplied by x minus 3. X times x is x squared, and 3 times negative 3 is negative 9. Well, when you get the middle parts, you get plus 3x and minus 3x. Those end up canceling each other out. So if you ever have the different sign but same variables and numbers inside, those cancel each other out. So what does that look like? Example number 2. T plus 5 and t minus 5 multiplied together end up canceling out, giving t squared minus 5 squared, which is t squared minus 25. In letter B, we have 3x plus y, 3x minus y. Special case. 3x times 3x is 9x squared, and then y times y is negative y squared. Make sure you note that the numbers positive times positive, negative times negative, those are still obviously true. All right. And then we'll do a special case over here. You can also do this with some products. So use special product patterns to find the product. Well, instead of just multiplying these out, which you can, obviously you can still do 26 times 34 your normal way, we can also use this same type of special case and split them up. Key here is to recognize some patterns. So they said, notice that 26, okay, is 4 less than 30, while 34 is 4 more than 30. Notice that we're using 30 for both. You always want to have that common term in there so we can get this common A or B in the situation. So we have 30 minus 4 and we have 30 plus 4. So notice that this is going to cancel out in the middle. So we can do 30 times 30 and do 4 times 4, and the middle is going to be canceling out, which makes it a little easier because 30 times 30 is 900 and 4 times 4 is 16, which we can find out that this actually equals 884. So yes, is it longer? Yeah, it's longer than obviously you plug into a calculator, but definitely another way to kind of visualize what 26 times 34 actually means. You just got to recognize what number they share in common and possibly what same subtraction amount or same addition amount there. So just recognizing the pattern in that part. All right. With that said, I think that kind of gives you a good snapshot. Here's some questions if you want to try. Go ahead and freeze it if you want to, and then I'll post the answers up here in a moment. So you have some practice problems to do. All right, and here's the answers. All right. Kind of check over them, make sure you are good to go. Hopefully that helps, and I'll see you in class.